Have you ever thought, what's out there, while you gaze up at the stars? Not just distant suns or flickering dots, but worlds, alien planets, some cold and lifeless, others maybe not. Now what if I told you that just 120 light-years away, something is happening that has scientists whispering the unthinkable? What if water exists there? What if carbon-based molecules are floating through its skies? What if, in the shadows of a red dwarf star, life could be hiding? This is the true story of K2-18b, a planet that might not only rewrite how we search for alien life, but challenge everything we thought we knew about what habitable really means. Strap in, because what you're about to hear is not science fiction. The planet that shouldn't exist. Let's start with the facts. K2-18b is real, not a theory, not a maybe. It's been spotted, measured, tracked. Discovered back in 2015 by NASA's Kepler Space Telescope during its K2 mission, this planet was lurking in a patch of sky 120 light-years away in the constellation Leo and orbiting a small, cool red dwarf star called K2-18. It's big, about 2.6 times the radius of Earth, weighing in at over 8 Earth masses. That puts it somewhere between a super-Earth and a mini-Neptune. It's too massive to be fully rocky and too small to be a gas giant. But here's where things get crazy. K2-18b is sitting right in the middle of the star's habitable zone. That means it receives just about the same amount of energy from its star as we do from ours. Liquid water? Possible. Temperatures? Potentially tolerable. But that's just the beginning. A breath of life. In 2019, something groundbreaking happened. The Hubble Space Telescope turned its eye toward K2-18b, and when the planet passed in front of its star, just a tiny dip in the light, scientists did something magical. They analyzed the faint signature of its atmosphere. The result? Water vapor is real. It's confirmed. Let that sink in. The first detection of water in the atmosphere of a planet within the habitable zone outside our solar system. And if there's water vapor up there, what might be below? Ocean? Clouds? Rain? But wait, there's more. In 2023, the James Webb Space Telescope picked up where the Hubble Space Telescope left off, and what it saw stunned the scientific world. Methane and carbon dioxide, and maybe, just maybe, a whisper of dimethyl sulfide, a molecule that, on Earth, is almost exclusively produced by life in the ocean. Is it conclusive proof of life? Not yet. But the ingredients are all there. Water, carbon, methane, a potentially Earth-like temperature, and something that smells like biology. Not another Earth. But don't let the hype fool you. K2-18b is not Earth 2.0. It's bigger, heavier, stranger, where the pressure below the clouds could crush a submarine, where the surface, if it even... This is a Hycan world. That's the term scientists now use, a hybrid of hydrogen and ocean. A planet with a blanket of hydrogen gas and possibly an entire ocean beneath it. And if this ocean exists, it's not just any water. It's likely boiling, pressurized, maybe even supercritical, neither liquid nor gas. Alien? Absolutely. But uninhabitable? Not necessarily, because there's something else. Life in the shadows. Let's go back, way back, to a time when Earth was unrecognizable. No trees, no animals, no breathable air. And yet, life found a way. Not in sunlight, but in darkness. Scientists believe that the very first organisms on Earth may have emerged in deep-sea hydrothermal vents, cracks in the ocean floor, where mineral-rich waters spewed into the abyss. These early life forms didn't need sunlight. They lived off the heat, pressure, and raw chemistry of the planet itself. Now think about K2-18b, a planet shrouded in thick hydrogen clouds, orbiting a star so faint it barely glows red. It's an ocean, if it exists, lying hidden beneath layers of gas and haze, under crushing pressure. But down there, in the dark, could something be alive? Maybe not like us, but maybe microbes, or plankton-like organisms drifting in a soupy alien sea. Creatures that thrive not on light, but on chemical reactions. Chemosynthesis instead of photosynthesis. Now here's the twist. The James Webb Space Telescope detected methane and carbon dioxide in K2-18b's atmosphere. And if those gases are in just the right ratio, it's hard to explain them with chemistry alone. It suggests biology. And then, There's dimethyl sulfide, DMS. On Earth, DMS is only made by life, tiny ocean microbes to be exact. If that faint signature is real, it's not just a hint, it's a message. A whisper from a distant ocean saying, "We're here, maybe not on Earth, but somewhere." Dangers in the dark. But it's not all wonder and possibility, because while K2-18b might orbit in its star's so-called habitable zone, its sun isn't exactly friendly. K2-18, the red dwarf it orbits, is no calm and steady guardian. It's volatile, unpredictable, known for sudden bursts of violent activity, solar flares that shoot out deadly ultraviolet rays and X-rays into surrounding space. Red dwarfs may be small, but they are furious. And K2-18b is sitting dangerously close. It always keeps the same side facing its star, much as our moon always has one side to Earth. One half fused forever in daylight. The other was shrouded in that cold, eternal darkness. And those flares, they don't just burn, they sterilize. They can strip the upper layers of a planet's atmosphere, breaking apart molecules and frying organic compounds before they ever get the chance to become life. So if life does exist on K2-18b, it's not sunbathing, it's hiding. Maybe far beneath the planet's thick hydrogen haze. Maybe deep under miles of high-pressure alien ocean where solar radiation can't reach. Maybe shielded by a layer of boiling water or supercritical ice, locked away in a pressurized, chemical-rich cradle. This isn't a cozy Earth-like paradise. It's harsh, violent, extreme. A place where life wouldn't just exist, it would have to endure. Why K2-18b changes everything. Here's the truth. K2-18b is like nothing we've seen in our solar system. Earth is a rocky terrestrial planet. Neptune is a cold, gaseous giant. But K2-18b? It lives in the in-between. Bigger than Earth and smaller than Neptune, it was an odd mix. Not solid, not gas, but something else entirely. And here's the part that flips the table. Planets like this, sub-Neptunes, aren't rare. They're everywhere. According to data from Kepler and other missions, they're the most common type of planet in our galaxy. That means K2-18b isn't a cosmic oddity, it might be typical. And that changes everything. For years, we've been searching the stars for planets like Earth. Same size, same temperature, same atmosphere, Earth-like, familiar, comfortable. But what if Earth isn't the cosmic blueprint? What if planets like K2-18b, Hycean worlds cloaked in hydrogen with hidden oceans, are the true havens of life? What if those deep, pressurized, chemical-rich oceans are teeming with microbial ecosystems, just different from our own? Think about it. Perhaps all along we were searching in the wrong areas. Life doesn't need a twin of Earth, it just needs the right chemistry, the right conditions, and enough time. K2-18b forces us to reconsider what habitable really means. It opens the door to a whole new category of planets and a whole new realm of possibilities. The next frontier. Right now, the James Webb Space Telescope is watching. More data is coming, more transits, more fingerprints of alien air. Future missions like ESA's Ariel will study hundreds more exoplanets like K2-18b. Each one a new possibility, a new hope, a new mystery. And with each discovery, the line between science and science fiction gets thinner. What if one day we confirm dimethyl sulfide? What if we detect chlorophyll or oxygen out of place? What if we find a signal that wasn't made by nature? It all starts here, with one world, one whisper, one strange planet, 120 light-years away, orbiting a cold red sun. K2-18b. Are we ready? So what does it all mean? Maybe nothing. Maybe K2-18b is just a hydrogen-wrapped ball of gas and boiling seas. Or it's more. Perhaps life has been waiting in the darkness between the stars, quietly, patiently, growing in alien oceans, sending out signals not in radio waves but in molecules. And maybe, just maybe, we've finally heard one. The universe is big. If your mind is blown right now, hit that like button. Subscribe for more journeys into the weirdest corners of our universe. Because this isn't the end, it's just the beginning.